Good evening, students. 9th standard science. We are in this session. We are going to learn about solutions. This is the topic of today's session. Yes, in previous classes we learned some knowledge about that solution. What is solution? Solution means it is in liquid state. Sit. There are three kinds of states: solid, liquid, and then gas. So the solution is the state of liquid. Solution, generally, all the solutions are in liquid state only. This is the first concept. Okay. And then next one is, in our day-to-day life, we are using different types of materials. Like what are that? Air, and then wooden material, water, and one more example, our body. So these are all these materials we are using in our day-to-day life. So what they are contains? Air contains different kinds of gases like carbon monoxide, carbon dioxide, etc. These kinds of gases are mixed in air. And then wooden material means it contains different kinds of materials. Wooden materials also carbon monoxide, and then air contain oxygen, nitrogen. Wooden material contains carbon monoxide, carbon dioxide gases. Okay. Water contains hydrogen and oxygen. These two are mixed in this water molecule. In our body, there are different kinds of materials. What are they? Blood, lymph, etc. So these are mixed in our body. So these are all the examples of solutions. Okay. Now we are getting some idea about what is solution. What is solution? Yes, air contains different kinds of gases, wood contain different kinds of materials as well as gas, and then water contain different kinds of molecules. Our body contain blood, water, urine. Different kinds of materials are present in our bodies also. So these kinds of materials are called as solutions. Okay, yeah. So these kinds of materials are called as solution. Yes, solution is a homogeneous mixture of two or more substances. Okay, so what is the concept of solution? Solution is a homogeneous mixture. Homogeneous mixture of two or more substances. This is the concept of solution. Solution contain different kinds of material. What are they? There are different homogeneous mixture of two or more substances. Okay. So it contains in two main part. What is that? One is called solute. Another one is called solvent. These two major part in the solution. Okay. Solute and then solvent. Okay. So solute means lesser quantity. Lesser quantity material is called as solute. Okay. And then solvent, higher quantity of that substance. So these two are the major parts of solution. One is a lesser quantity substance. Another one is a higher quantity substance. Lesser quantity is called as solute. Higher quantity of substance is called as solvent. So now we are learning what is solution, what are the examples of basic concept of solution, and then what is the concept of solution, what are the main component, major part in that solution. Okay, here, and next one is there are different kinds, that is homogeneous solution and then heterogeneous solution. Next heading is homogeneous and then heterogeneous. What is homogeneous and then heterogeneous? Yes. Homogeneous solution means it is the one kind of solution. Okay, homogeneous means it is one kind solution distributed uniformly throughout the solvent. Okay, yeah. So uniform distribution. Uniform distribution is called as homogeneous solution. The solute is distributed uniformly throughout the solvent. Actually, the solute is dissolved in solvent. So this is the preparation of solution. Solute is dissolved in solvent. So the solute is uniform distribution, means that solution is called as homogeneous solution. Okay, yeah. How the solute is distributed? Yes, it is in uniform distribution. Another one is heterogeneous. Heterogeneous solution. So this is the opposite. Yes, heterogeneous means in this solution, non-uniform composition of the properties throughout the solution. It is not an uniform. So non-uniform distribution. This kind of solution is called as heterogeneous. Okay. So homogeneous solution means, example, salt plus water. So when we add salt or sugar in water means completely sugar and the salt is dissolved into the water. Water acts as a solvent. Sugar and salt act as a solute. When we want to add some amount of salt or sugar into the water means these two materials are completely dissolved into water. That solution is called as homogeneous solution. Understand, pa? This is called as homogeneous solution. And next one is heterogeneous, that is non-uniform distribution of solute. When we add some amount of sand or husk, these two are not dissolved in water. These two are the solute. Water is a solvent. When we add some amount of quantity of that sand or husk means these two materials are not dissolved in water. This kind of solution is called as non-uniform distribution of that solute. So it is called as heterogeneous solution. Okay, yeah. One is homogeneous. Homogeneous means solute is completely dissolved, uniform distribution. But heterogeneous solution, when we want to add these two materials, after some time, it was settled under the bottom of the container. That is called as heterogeneous solution, non-uniform distribution of the solute particles. Okay, yeah? So just I'm going to show this examples. These are two beakers. One is Just I add some water into this beaker. Water acts as a solvent, is it? Yes, first I add some amount of water in these two beakers. So water is a solvent. Okay, these two beakers contain the solvent. Just I am going to add solute material. Solute. What is the solute? Yes, I add some quantity of salt. Salt is a solute. So currently I'm stirring the salt. So completely within few minutes, the salt is completely dissolved into the water. Just you see, after few minutes, the salt is completely dissolved into this water. So this is called as a homogeneous solution. This beaker contains only water. Just I am going to add some material like husk. Okay. Husk material is not dissolved in water. Yes, it is floating on the water, or otherwise it will be settled bottom of the water. Depends upon the density that material is floating or settling. So the density is very low, so it is not dissolved. So this is called as heterogeneous solution. Look at this beaker. One or two salt particles only not dissolved, remaining part is completely dissolved. So this beaker contains the homogeneous solution. This beaker contains a heterogeneous solution, that is, that particle is not dissolved in that water. So basically solution means large amount of solvent, that is water. Water acts as a solvent, salt acts as a solute. So this is solute. Just I add a pinch of salt only into this water. So this is called as homogeneous solution. This is called as heterogeneous. Solvent is water. Solute is some amount of husk. The husk is not dissolved in this water. So this is called as heterogeneous solution. Is that clear? What is homogeneous solution? And then what is heterogeneous solution? And how to make the solution. So the solution means solute is added into solvent. The solute is complete dissolved means that is called as homogeneous. And another one part is heterogeneous, it is not dissolved. And then one more concept, this is the dissolution concept. Dissolution concept means uniform distribution of the solute into the solvent is called as dissolution. Yes, the salt is uniformly distributed in this water. So this is called as dissolution. Okay. So next topic means this is homogeneous and then heterogeneous. Okay. Another one is binary and then ternary solution. So this is binary solution because only one solute is added into the solvent. Solvent is a water, solute is a salt. Only one solute is added in this beaker. So this is called as binary solution. And now I am going to add another one material, that is sugar particle. Okay. One more solute. So this is the cubical sugar. Going to add this beaker and stir gently. The sugar also dissolved in this beaker. Just wait few minutes. So now I am adding some amount of sugar also into this beaker. Already salt was dissolved in that solution. Apart from that salt, I add some sugar also. So there are two solutes in this solution, one solvent. So this is called as ternary solution. Solution which made of one solute and one solvent is called as binary. And then more than two components, that is solute is added in that to solvent, means that is called as ternary solution. And one more example, when we want to prepare lemon juice, means we need solvent. See this beaker. Yes, the sugar also dissolved in this water. So this is the ternary solution example. Okay. So what are the two concepts? Homogeneous solution and then heterogeneous solution and then binary solution and then ternary solution. Clear, ma? So these are all the different kinds. Okay. So what is binary and ternary? Binary solution means one solute and one solvent. Okay. Binary solution. What is binary solution? Made of one solute and one solvent. So, when we prepare with the help of one solute and one solvent, that kind of solution is called as binary solution. Example, solvent is water. Water acts as a solvent. Okay. Solute. Salt. So, binary solution, salt is dissolved into the water. So, the salt water solution is called as binary solution. Okay. So, next one is ternary solution. Next is ternary. So, ternary solution means more than two components or more than one components or more than two components are dissolved into the water. When we use more than two components. So, here solvent is a water and then solute, sugar and salt. So, these two are the solutes. These two solutes are dissolved into water. So, sugar salt solution is the example of ternary solution. Sugar, salt is dissolved into water. So that is called a sugar salt solution. It is the energetic drink also, sugar salt solution. When we bought our body will be dehydrated, means immediately we want to take this kind of solution. This is the energetic drink also. Just we take 1 cup of water and add some amount of sugar and salt completely. After the dissolving, we will be take that condition, means immediately we will get the energy. So loose motion condition or high temperature, in that kind of time we want to take the sugar salt solution, means it will be give the energy also. Okay, yeah. So this sugar salt solution is the example of ternary solution. Okay. So, and next one is the another some different kinds of types of the solution. What are they? Types of solution. Yes. First, based on the physical state of the solute and the solvent. Yes, matter is three states. Okay, sorry, liquid and gas. Yes, matter is exist as these three states. There are the major states. Depends upon the states we want to classify the types of solution. First one, based on the physical state. Based on the physical states. How we can classify? Yes, first one is major part, solute, and then solvent, and then what are the binary solution is called as? Binary solution, how can prepare? What is the solute? Yes, there are three states, solid, liquid, and gas. First, I'm choosing the solid state. What is the solid? So, solute and the solvent both are in same state, that is solid state. Okay. Solute and solvent both are in same state means what is the example of this solid material means copper and gold. Okay, yeah. When we want to add copper and gold, copper is dissolved in gold material. This is called as alloy. Okay, yeah. So, when we add copper and gold material means this two materials added and prepare that solution means that material is called as alloy. Okay, so this is the example of solid materials. Based on the physical states, there are three kinds of states. First, I want to add the solid and solid state means both are in solid state, copper and gold. So this mixture is called as alloy. And next one is liquid and solid. Liquid and solid. So what is the example? Mercury. See, mercury is a liquid state and sodium is solid state. So this is a liquid state. This is solid states. These two materials are to join to frame one material, that is called as amalgam. So this kind of mixture is called as amalgam. Okay, yeah. So what is the solute? Solid in state. Solvent also in solid means the example of the mixture is that is copper and gold mixture. And then solute is in liquid state. Solvent is in solid state means in this mixture is mercury and sodium. These mercury liquid is dissolved into sodium solid state, sodium pellets. It is in that pellet formation only. So it is in liquid state materials. So this mixture is called as the amalgam. So solid and solid, liquid and solid. And then next one is liquid. First one is solid state. Next one is liquid. Solute, solvent. What is the binary solution? So this is the heading. What is the solute? Solute is first one solid and liquid. Example of solid is sodium chloride, NaCl, normal salt. We are using the salt in our cooking, and then the salt is called as sodium chloride. This sodium chloride is dissolved in water. Okay. So solid material example is sodium chloride. Liquid material example is water. completely sodium chloride is dissolved in water. Okay, so this is the example of solid liquid solution. And then next one is liquid and liquid. Both are in liquid state. So liquid state means ethyl alcohol. Ethyl alcohol is one example of liquid, and one more example. Liquid state means that water. Yes, completely ethyl alcohol is dissolved into water. So this is in this solution is example for liquid mixture. Okay. Solid liquid mixture means NaCl and water. NaCl water solution is the example of solid and liquid solution. Liquid material means ethyl alcohol and water. So this ethyl alcohol is completely dissolved into water. So this is the example of this. So solid is over and then liquid is over. Next one is gaseous state. Yes. How the gaseous state is possible? Yes, that is also possible. In gaseous state means what is the solute and solvent binary solution, because only one solvent, only one solute we are taking to prepare the solution. So this is called as binary solution. First one is liquid and solid. Liquid and gas. So this is the gaseous topic. So liquid and gas. Yes, water vapor in air. Water vapor in air. So water vapor air. Water vapor is a liquid only, is it? Water vapor is a liquid state only. Water is evaporated into the and the next stage, that is it was evaporated, means it will be changed to the gaseous state. So this is the example of liquid, and then air is the gas. So this is the best example of gaseous solution. In gaseous solution, liquid particle is in water vapor, and then gas means example is air, and gas and gas. Gas means mixture of helium and then oxygen gases. In atmospheric air, different kinds of gases are mixed in this atmosphere. So, helium and oxygen. This mixture is a good example of gaseous state. So, the gaseous solution means helium and that oxygen mixture. Liquid and gas means water vapor and air. So this is the example of liquid gas solution, that is in gaseous solution. This is the third. So gaseous solution means solute is a liquid, solvent is gas. Solute is gas and solvent also gas. These are all the example of this kinds of solution. So is that clear, ma'am? Types of solution means depends upon the states, physical states, solid, liquid and gas. Just we learned different kinds of solution in that heading. Okay, next, based on that type of solvent, different kinds of solvent, we are going to learn the solutions. Okay, based on type of solvent. Yes, what is the major solvent? Yes, very good example, well-known example. Yes, water. Water is the major component of the solvent. 95% of materials are dissolved in water. water. So the water is called as universal solvent. Okay. So water's universal solvent means universal solvent is called as water. Water is also called as universal solvent. Why it is called as a universal solvent? Because in our earth, 95% materials are dissolved in water. So it is called as universal solvent. Where is the remaining 5%? Yes, some substances also act as a solvent, like ether, benzene, and alcohol. These are also act as a solvent, that 5% solvents. 95% solvent means water, remaining 5% solvent. The examples are ether, benzene, alcohol. These are all some chemical components. So these chemical components are act as a solvent. Some materials are dissolved in these materials. So this is called as aqueous solution, and then a non-aqueous solution. These types of solution also classified into two types. That is aqueous solution. Aqua means what? Water. So 95% materials are dissolved in water means that kind of solution is called as aqueous solution. Aqueous solution means which water acts as a solvent is called as aqueous solution. Salt and then sugar, these are all dissolved in water completely. So this is called as aqueous solution. Non-aqueous solution. So non-aqueous solution means this some 5% of material is dissolved in ether, benzene, and alcohol. So these kinds of solution is called as non-aqueous. It is not dissolved in water. Okay, yeah. Sulfur dissolved in carbon dioxide. So this is the example. Sulfur dissolved in carbon disulfide is the example of non-aqueous solution. Non-aqueous solution is any liquid other than water. What are they? Ether, benzene, alcohol, like that. So these are all act as a solvent. So these kind of solution is called as non-aqueous solution. Okay. And next one is based on the amount of solute. So before that, we are going to see one simulation. Yes, this is from this simulation, we are going to learn the concentration. Concentration. What is the concentration? Concentration means the solution may be prepared with the help of solvent and the solute. These are all the main major component to prepare the solution. That concept is clearly understood. So how can we define the concentration? Mean concentration of a solution may be defined amount of solute present in the given amount of the solution. Okay, yeah. So this is the concentration concept. What are the components to do the simulation? Means this is the concentration indicating component. One beaker. The measurements also indicated here, half liter, 1 liter. So this is 1 liter container. Okay. And then two types of solutes also available. Two states. One is in solid state and another one is solute. Solution state. We are available that we are having the solute states. One is in solid, another one is, and then solution, liquid states. Okay, and this is the solvent. Okay, sorry, solvent example is cobalt nitrate. Sorry, solvent is the water. These are all the solute example. Cobalt 2 nitrate, cobalt 2 chloride, potassium dichromate, potassium chromate, like that. These are all the examples of solute. Water is the solvent. Okay, so now I'm choosing copper 2 chloride. Want to remove the water in this beaker. So I spread the solute into the beaker. Cobalt 2 nitrate is the solute. So next, solvent. Yes, I add half liter of water in this beaker. Water is a solvent. Cobalt 2 nitrate is the solute. CONO3 twice is the formula of cobalt 2 nitrate. It is in solid state. Okay, now going to identify the concentration of the solution. Yes, the concentration of the solution is 1.491 mole by liter. This is the unit. 1.491 is the concentration of the solution. So now I'm going to add some amount of solute. Look here. Yes, the concentration is increased because I added some amount of solute. So the concentration of the solution also increased. See here, I want to add some amount of water. Yes, 1 liter. Yes, the beaker contains 1 liter of water. See here, what is the concentration? Yes, the concentration level is decreased because the solvent quantity is increased. So the concentration also changed. So this is the concept of concentration. The quantity of solvent and the quantity are the solution to essential for the concentration of the solution. So how much amount of solute is added into the solvent, that is the main concept. So I want to remove this. So I'm going to choose potassium chromate. Yes, potassium chromate is in yellow color. The formula of potassium chromate is K2CrO4. Add water. Yes. See here, the saturated. Yes, the saturated term is, we are reading here. Why it is called as saturated? Because the solvent quantity is lesser compared to the solute quantity. Yes, I pour higher quantity of solute this beaker. So this solution is called as saturated, and as well as the concentration level also higher. 3.350 mole per liter. So this solution is called as saturated. Concentration. The concentration is higher means that is called as saturated. I'm adding some water, half a liter. Immediately the concentration level is decreased. Yes, 2.415 mole per liter. So the concentration is decreased. Why? Because of the solvent amount was increased. Here also I am adding some water. Yes, 1 liter water contains some amount of potassium chromate. this concentration is, this solution contain 1.298 concentration level only. Concentration concept is clear, students? How much amount of solute is dissolved in that solvent is concept of the concentration. Okay. So, remove the solute only. So, this beaker contains the solvent. I am choosing the solution part, that is liquid part. So, the solute is in liquid. K2Cr2O7, that is the formula of potassium dichromate. I am adding some amount of liquid potassium dichromate. The light orange color is occur here. What is the concentration? Is 0.050 mole per liter, because lesser amount of solute is adding here. So the concentration level is very low. At some amount of potassium dichromate, the concentration level is increased. Solvent level increased means the concentration also decreased. So, depends upon the solute, the concentration level is changed. So, to remove the solute, sodium chloride, normal salt solution. Okay, adding the salt. Sodium salt pellet. So, see the level of the concentration. So, 1.103 mole per liter is the concentration of the solution. So, the amount of solute is higher. So, the concentration also higher. When I add some amount of solute means immediately the concentration level also increased. So, with this help of the simulation, we learned what is the concentration. Concentration means how much amount of solute is mixed in the solvent. So, that is the concept of concentration. Okay. So, clear, pa? And next one, how to prepare the solution. What is the solution means? Yes. How to prepare the solution? Yes, simply. We already see that practical. This is called as salt. This is beaker contains some amount of water and stirrer, tripod stand, and then burner also. In this process, we are going to learn the reversible and then irreversible concept also. So, I'm taking some amount of salt. So, this is the solute, because the solute quantity is very little. Okay, so only one spatula salt is added in this water. Water is a solvent, salt is a solute. Water is now the water contains little bit amount of solute. So, this is called as solution. I'm taking the stirrer. So, the salt is completely dissolved in the solution. So, this is the solution. And also, this is called as a binary solution because the salt is completely dissolved into water. Water is a solvent and then salt is a solute. I add some amount of salt into this beaker, the solute is completely dissolved into the solvent. So this is called a solution as well as the binary solution. What is reversible reaction? When I heat this beaker means the water is evaporating here. The salt content is settled under the beaker. So this is the example of a reversible reaction, because once again the salt, we got it though. So dissolution of common salt in water is a change which can be reversed because salt can be obtained back the evaporation of the water. So this reaction is called as the reversible reaction. That is, salt solution is heated means the salt is once again settled under the beaker. Next one is very simple example. This is knife and this is potato. I'm going to cut the potato. Yes, one potato is cut into two pieces. When I want to join this potato means, so it is not possible. So this action is called as irreversible reaction. So cutting potato into pieces is change which cannot be reversed. So this is called as irreversible reaction. Okay, yeah. So reversible reaction means the salt is once again settled under the beaker. The potato is not joined. So this is called as irreversible reaction. So we learned what is the concentration level and also what is the reversible and then irreversible reaction. And then next topic is based on the amount of solute. How can we classify the solution? That is the next heading. What is the next heading is based on the amount of solute. Already we learnt amount of solvent. Here, based on the amount of solute, depends upon the amount of solute, we can classify the solution into three types. One is saturated. And then another one is unsaturated. And third one is supersaturated. So these are all the three kinds, depends upon the amount of solute. Saturated, unsaturated, and then supersaturated. Saturated solution, unsaturated solution, and then supersaturated solution. Saturated solution means that is more solute. In this solution, which no more solute can be dissolved in that definite amount. That is called as saturated solution. That is proper percentage, proper proportion. Okay, yeah. So proper proportion means that is called as saturated solution. When we want to prepare the saturated solution means, example, 100 gram or 100 ml of water, that is the solvent. Solute is 25 gram only. So in this manner we add means that kind of solution is called as saturated solution. That is the minimum normal amount of solute is dissolved in solvent means that kind of solution is called as saturated solution. So 100 gram of water, 100 ml of water contains only 25 gram of salt means that is the example for saturated solution. Next one is unsaturated solution. Unsaturated solution means that contains the less amount of solute. less amount of solute is contained the solution means that is called as unsaturated solution. Example, 100 gram of water, 10 gram of salt is dissolved here means that is called as unsaturated solution. 10 gram only dissolved here. In 100 gram of water contains only 10 gram of salt means that solution is called as unsaturated solution. Unsaturated solution contain the less amount of solute. Water is a solvent, salt is a solute. So this amount is very less compared to the saturated solution. Supersaturated solution means higher amount of solute compared to the saturated solution. Higher amount of solution is added one word. So solvent means that solution is called as supersaturated. Supersaturated solution contains higher amount of solute. So this is called as supersaturated solution. Example, 100 gram of water, 40 gram of salt. Okay. So this is the higher quantity of solute. Normal saturation means how much amount? Only 25 gram is the normal quantity. When we want to prepare 1 cup of coffee means we add only 1 spoon sugar means that is called as saturated solution. A cup of coffee adding little bit of sugar, that is diabetes patients add some little amount of sugar only. That solution is called as unsaturated solution. By mistakenly, I added 4 spoons of sugar in a cup of a coffee prepare means that is called a supersaturated solution. A single cup added 4 teaspoons of sugar means that is called as supersaturated. Only 1 teaspoon sugar means that is called as saturated. Only 2 or 3 cubes only added means that solution is called as unsaturated solution. So this is the explanation of the saturated, unsaturated and supersaturated solution based on the amount of solute. When we want to prepare the saturated means the salt is completely dissolved, and then unsaturated also completely dissolved, and supersaturated means that solute is not dissolved in that area. So this is the main concept of that saturated and then unsaturated and then supersaturated solution. Okay. So now going to prepare the saturated and unsaturated. Yes. So this beaker contains the 100 ml of water. 100 ml means I'm going to take the level of 1 test tube. So this test tube water is added, this beaker. So first this is the saturated solution. So saturated solution means how much amount of salt we are going to take the 25 gram of salt. 25 gram of salt going to add in this beaker. So this is the saturated solution. Saturated solution means yes. So this is the 25 gram of salt. So I'm adding the salt into this beaker. The salt is completely dissolved. When I'm stirring means the salt is dissolved, completely dissolved in the 100 ml of water. So this solution is called as saturated solution because the solute amount is normal quantity. 25 gram is the proper proportion. So this is called as homogeneous solution. Sorry, saturated solution. Okay. And next one, the same amount of water only I am taking. Yes. Same amount of water. There is no difference in the solvent, but the solute amount is differ. Only 10 gram. 10 gram of salt only I am going to add it to the solvent. So 10 gram is lesser compared to the saturated solution. So I'm adding that 10 gram of salt. Once again, stirring the solution. So it is also completely dissolved because the solute level is very low. So this solution is called as unsaturated solution. Completely the 10 gram of solute is dissolved in this solvent. So this is called as unsaturated solution. And then next one is supersaturated solution. Supersaturated solution means that solute gram is higher compare the saturation because the saturation level is 25 gram only. Set. So the solvent is in that same level, but the solute level is higher than the normal saturation. So the amount of solute is higher than the saturation solution. So 40 gram of salt is adding the water. So what is going on here? Yes, now I'm stirring the water means it will take more time to dissolve. Okay, yeah. So this kind of solution is called as supersaturated solution, like seawater. Seawater is so salty because large amount of salt is contained the seawater. So it is in the taste of so much of salty. So like this, 100 ml of water contain 40 gram of salt means this type of solution is called as supersaturated solution because the normal level is higher. So this is called as the supersaturated solution. So this is also clear, ma? Based on the amount of solute, we can classify the solution into three types like saturated, unsaturated, and then supersaturated solution. Next one is the concentration. Concentration, like what is that? We compare the two solution having the same solute, but that concentration level is differ. So that is called as the concentration. Already we understand the concept with the help of the simulation. Concentrated and the diluted. Concentrated and diluted solution. What is concentrated and the diluted solution? The amount of solute is higher. So the two solution having the same solute and solvent, but that amount of the solute is higher compared to these means that is called as the concentrated and the dilute solution. Okay. I'm taking the two beakers, adding some water, the same amount of water only. So the solvent level is same. I'm taking this solvent, that is the 100 ml of water. So Next one, I'm adding the coloring agent. This 2 beaker. The coloring agent is added, this beaker. Look at the solution. Wow, orange color is occur here. Please compare these two solutions. Yes, this beaker looks like a light orange color only, but the second beaker color is very high, dark in color. So this is the concentrated. This is the concentration of the solution. This is called as the diluted solution. This is called as concentrated solution because the amount of solute level is very high. The same solvent, same solute, but that amount is differ from these two. So this is the difference of concentrated and the diluted. Okay, yeah. So concentrated and the dilute solution. So sorry for the delay, students. I think in this session, I recall what is solution, what are the topics we learned in the session, what is solution, concept of the solution, what are the kinds of solution, types of solution, homogeneous, heterogeneous, binary and ternary, and then based on the amount of solute and then solvent, in this level also we can classify different kinds of solutions. So these concepts are very clear, I think. Is there any doubt? Means please raise your hand or put emoji. What is that? You can understand me. Just you explain, yes, the topics are clear, or otherwise, you please ask me which topic is not clear. Means definitely I will explain the same concept in the next session also. Is that clear? All the topics are very clear, means please go and read all the topics. Is there any doubt will come, means go and ask in the next session. And one more task, please give me some example of binary and ternary solution. This is the task of your today's session. Today's task is very simple, related this topic, that is examples of binary and ternary solution. Please write it and tell me that what are the binary solution example, what are the ternary solution example we are using in our day-to-day life. That is very easy. So please write some example for binary and the ternary solution. That is the concept, that is the task of today's session. Easy? Please do it and answer me in the next session. Okay, thank you, students. Jai Vidya Shakti. Jai Hind, Jai Bharat.